And welcome back. It's the 22nd of May, Further Maths 5 a day, and let's just go straight to the first question. First question is sketch the graph of, and then it actually tells me here importantly what it wants. So it wants the coordinates of any points of intersection, and that's it. So sometimes it might say, let me just zoom in a little bit, and sometimes it might say, I don't know, the line of symmetry or the vertex or similar. So this time it just wants the coordinates. So the easy one to start with is if x equals 0, then y equals 7 because the x's disappear. The harder one is y equals 0. So in other words, for this, I'm going to have to solve. So the first thing I'm going to note is, can I factorize this? And as ever, if you've seen any of my videos, I think I can. I'm basically going to put a 3 and a 4 and a 7 somewhere. Now I'm going to note that 3 times 7 is 21. And if I take away 4, I get 17. So actually that feels like that's right, doesn't it? So it's going to be 3x plus 1 and 4x minus 7, because 3x times minus 7 is minus 21. Add back 4. Happy with that. Crucially, that means my intercepts or my roots are minus 1 over 3 and 7 over 4. So very roughly, so minus 1 over 3 means I'm leaning this way around. The question will involve you getting the vertex on the right side. So that's going to be minus 1 over 3. That's going to be 7 over 4, and then this crossing point here is minus 7, and I've answered the question. That's all it needs to know. Next question. Okay, so this question is quite a nice question, isn't it? Because, and I think in the exam, it might give you a little bit more help, so maybe a grid just to be absolutely sure, but I think I know where this question's going. So the question basically is, instead of giving you a set of equations and says, can you plot these equations? This one's giving you the plot and saying, what are the equations? So it's relatively straightforward. You can see, in fact, I'm going to change the color because then I can show you what I mean. So you can see that up to minus 4, this is a straight line. So I can see why between minus 10 and 4, minus 4, it is plus 16. Then this is a parabola. Now, again, this isn't super precise, but I can see that 4 goes to 16 and minus 4 goes to 16. So I'm fairly sure that the equation here is going to be x squared, and that is between, I'm going to write it above rather than squeeze it in, that is between minus 4 and 4. Now, just on this, I need to make sure that that symbol there is not the same as that symbol there. So one's an equals, one's not an equals. You shouldn't get penalised for that, but just in case, so you're aware. Then down here, I've obviously got a straight line. Now, what do I notice about that straight line? Well, I can see that this point here is 4, 16. And I can see that this point here is 10, 0. So in other words, I'm going down by 16 and I'm going across by 6. So therefore, that means my gradient is minus 8 over 3. This isn't a very nice question, really, is it? It's a slightly difficult bit to end on. Now, what do I know? So y equals mx plus c, so y equals minus 8 over 3x plus c. I'm going to use 10, 0, because that seems like a slightly easier set of numbers. So therefore, y equals 0, x equals 10, which is minus 80 over 3 plus c, which means that c equals 80 over 3. So in other words, the equation here, I'm going to write it above again, is going to be y, actually it's not y, because it's in the fraction format. So just the equation, so it's going to be minus 8 over 3x plus 80 over 3. And that's the final bit done. It's already given me the range, so the range is okay. It's a good question. That's quite hard, that question, but it's a good question. I like that question. Next question. A curve has equation, given an equation. The gradient of the curve at the point P is 9. Work out the coordinates of the point P. Because it's a gradient, I'm definitely differentiating. So dy dx is 2 times 2, which is 4. Let's just write the 4 straight in, which is going to be 4x minus 3. And I need that to equal 9. So in other words, a gradient function must equal 9, which means that x is equal to 9 plus 3, which is 12, divided by 4, which is 3. That's not a coordinate, that's just an x value. So then I'm going to use my coordinate equation to work out my y value. So in other words, my y value is going to be 2 times 3 squared, which is 9, minus 3 times 3, the x value, plus 1. 2 times 9 is 18, minus 9 is 9, plus 1 is 10, which means my coordinate of P is going to be 3, 10. Good, well-worded question, clever question. Next and final question today. Describe fully. Fully seems relevant. The single, now I think I know why it's saying this, that's because there's a couple of ways of describing transformations. It just wants the one. Single transformation represented by this here. Now, if you see my videos before, you know what I do here. So I'm thinking about what's happening to 1, 0. So 1, 0 has become 0 minus 1. In other words, it has become down to here. It's sort of rotated round. Looks like it's rotated round. Then I'm going to think about what happens to 0, 1, which is this point here. And 0, 1 has become 1, 0, which is this point here. So this is definitely, just by looking at what's happened there, a rotation, the name of the transformation, by 90 degrees, i.e. how much is happening, which direction is clockwise, and the centre of rotation, so I'm going to put about 0, 0, and you need all of those things in. And that is today done. Again, as ever, decent mix of questions today. That graphing one, the second one, first time we've seen that, so we might have a few of those to come. Really enjoyed today. Let me know how it went from your side. Any questions, let me know. Do like and subscribe, really helps the channel grow a little bit more, and I'll see you for the next one. Thanks all.